Good afternoon, everybody. I'd like to welcome you to our next session titled Quantum Cyber Risk, How Deep and How Wide. Please help me welcome our panelists to the stage.
All right, thank you very much. And thank you all for being here and listening to the panel. There are a number of presentations and panels on this topic this year, I've noticed. But I hope that you'll get something additional out of this one. My name is Colin Suter. I'm a managing director at Deloitte based in the Washington, D.C. area. But I'm the global lead for our quantum cyber readiness topic. We've been looking at this for about 4 years or so. And I really feel like it's moving along and people are starting to take more attention. So maybe we'll go down just quickly. If you could just introduce yourselves, and I'll come back with the first question. Do you mind, Graham?
Thanks, Colin. Hi, everyone. I'm Graham Steele. I'm the head of product for the cybersecurity group inside Sandbox AQ. Sandbox AQ is a spin out of Google X, positioned around two foundational technologies, AI and quantum. And the cybersecurity division is principally concerned with helping us prepare for the post-quantum age when there's a threat from a cryptographically relevant quantum computer. And so we make software products that help people find their cryptography and prepare for that transition.
Thank you. Christian?
Great. My name is Christian Lowry. I'm the branch chief for emerging risks in the DHS CISA National Risk Management Center. So I lead a team of analysts focused on quantum and AI and other emerging risks, specifically focused on emerging technology.
Awesome. Ken DeRozzo. I lead Dell Research. We have about 150 researchers worldwide. We've been participating and active in both quantum computing and post-quantum cryptography for approximately 7 years.
Mike Jenkins. I work for NSA, Center for Cybersecurity Standards. I won't bore you with what NSA does, but the Center for Cybersecurity Standards is our outreach to ensure that the secure protocols and the infrastructure that we use is prepared for national security use, national security information.
Thanks, Mike. And by the way, I drew the short straw to wear the tie today. So maybe just to set the stage, and I think probably most of you here would understand what we're talking about here, but really want to focus the conversation around the mitigation of the potential threat that quantum computers in the future, as Gray mentioned, the cryptographically relevant quantum computer would pose to asymmetric encryption algorithms. The expectation, and NIST actually confirmed or put it forward that as a public statement that the standards that they've been working on, the 3 standards, the so-called Federal Information Processing Standards, are likely to be issued mid to late July. So, some people are saying, well, that's great, we just need to upgrade and that'll be it done. But no, I mean, we all see it, I think, as that's the starting gun, right? There's lots of other steps that need to take place after that. And that was the basis for the panel here, trying to look at different stakeholders' views on what is required after those standards are released, what sort of additional steps. So maybe, Christian, if you don't mind, I'll start with you in terms of CISA's role, and because that fits right in your purview, right, in terms of emerging tech and helping to deploy it across critical infrastructure.
Yeah, that's right. And so, DHS and CISA have laid out a few steps, and I think it's helpful to highlight just a couple of them. And there are things that can be done now and should be done now, even in advance of the standards coming out. And so, what we're trying to emphasize very consistently and, very specifically for critical infrastructure is that you can test now with the drafts that have been released, and you should test, and you should conduct an inventory now. And that's not just for, what crypto systems you have in place, but what data you have in place that you need to protect, and you should understand how long you need to protect it specifically. And I think what we've seen is that is not just a quantum consideration, that is a cyber consideration. And so that good work to get ready for implementation of these standards would also elevate your overall baseline by helping you with any other transition you might need to undertake.
Sounds good. And then, Mike, I know when we were chatting before, I think obviously there's national security systems that are in NSA's purview, but I think you've also got an interest in some of the testing protocols that will likely come up around these algorithms. Could you maybe speak a little bit about that?
Yeah, so there's kind of the algorithms that come out from NIST, but once that happens, of course, there's a lot of testing, especially especially for national security systems. There's NIST cryptographic algorithm validation program, cryptographic module validation program. But then on top of that, we do basically common criteria, national information assurance program. And so there's several steps that we have to go through in terms of writing documentation and creating tests that like lengthen our chain to getting from just when the FIPS drop to when we can actually buy product.
Okay. And in some of the conversations this week, I think again, the update of algorithms now that when the FIPS will be released is one step, but really it's a step in a longer path. There's the notion of crypto agility, which talks about the ability to change multiple times. But then I think even above that, there was some discussions yesterday we were involved with around the notion of crypto resiliency. So looking at the overall governance and key management. I wonder maybe, Graham, you could talk a little bit about that. And then Ken, I'd be interested in your thoughts after that about how that's being advocated across different sectors. But maybe if you could talk to crypto resiliency first.
Sure, yeah, I mean, it's really interesting to see how things have changed over the last 12 months, I would say. We were involved in projects 12 months ago which were really aimed at the PQC transition principally, so big budgeted, high-profile projects in large enterprises. But what we're seeing now is that there's another range of these projects where we're seeing this more as a general cyber move, right? So it's like I'm looking for resilience, I'm looking for visibility, I'm looking for all these good properties with my other cybersecurity assets, so why don't I have that with my cryptography? But that also gives me the flexibility I need to make that PQC transition. So it's part of something that the CIO is interested in, the CTO is interested in, not just a kind of pure CISO initiative as it was being seen a little bit before.
Yeah, and thank you, Graham. And then Ken, as I alluded to, I think with your scope of purview in terms of other emerging tech as well, I wonder if is this the same sort of emerging tech disruption as you've seen before, or is this one different? And how do we communicate it differently to executive level people?
Yeah, I think that there's probably three parts to the dialogue. The first one is this: we have seen previous shifts in cryptography over the years. How many of you remember DES? Yeah, and the transition from DES to triple DES and AES, et cetera. So we've seen general cyber hygiene happen, and we should be thinking about this predominantly as a cyber hygiene type of thing. And I'm stressing that point. I often get asked, when is a reasonably sized quantum computer, a sufficiently sized quantum computer, going to be available? And people use that as the benchmark for thinking about when they should replace cryptography to be protected. We shouldn't think like that. We should think of it as normal cyber hygiene, making sure that we're up to date on our algorithms and that we are taking appropriate approaches to risk mitigation there. The third leg to that is, I often talk about Y2K. Now, most people, how many of you think that Y2K was a big deal? Not very many. Most people didn't think it was a big deal, but it was actually designed to not be a big deal. We knew the target date, we knew what needed to be done, we knew all the things about it, and so we were prepared accordingly to make sure that it was a non-event when it happened. And so I think that last part is an interesting thing. We don't have that right now. So the best thing that we could do, instead of worrying about when a sufficiently sized quantum computer will exist, we should be thinking about the cyber hygiene part instead.
Yeah, and that's an interesting point. I mean, I think that there's often, in panels sometimes, not panels, but just discussions in general, and I've seen it on a number of panels where, there's a lot of discussion about when is it going to happen and so on. The way that we really put it is, if you accept that there's a finite probability that it's going to be here, let's say in the next 5 to 10 years, small but finite, how long is it going to take you to upgrade your infrastructure, to your point, right? I mean, do you know how long it's going to take you? And so getting a head start, I think, not only allows you to know what the risk is, but then it allows you to leverage other programs along the way as well. To that end, maybe Christian, back to you again, is CISA thinking about how to sort of help encourage across, like what sort of tools, and I know it's probably early days still, but what sort of incentives or tools or encouragement do you think might be there?
Sure, I think those are the right words. We're not a regulatory agency, and so we are certainly approaching it from an enterprise risk management perspective, I would say at this point, in terms of thinking about it in terms of those trade-offs of risks and how to manage and mitigate them. And so, I'll say, for the federal civilian executive branch agencies, we're actually leading the work and leading the management of an inventory of cryptography across those systems. And so we're hoping that sets an example of how to do things and that we can put guidance out on, in a generic way about how to conduct those inventories, because I do think that's a critical first step, and that's for that reason, that's why the federal government is taking that step first for its own systems.
Okay, good. And are you seeing from your purview, seeing industry groups farming as well on the private sector side? Do you see some of that going on?
We're seeing a lot of interest, and so there are some groups standing up. I think there will be a natural progression where the standards come out, and it's likely that there will be sector-specific considerations of those standards and the specific implementations needed for the financial services sector or the telecommunications industry or whatever that is. And I think that is actually, as much as I think a unified national approach would be helpful in some ways, I think it's natural and actually beneficial that those sectors and those industries tailor-make their own solutions, because they're going to need their own standards. They have very different implementations, and they're going to have very different levels of complexity and levels of investment required to execute a transition. And so if you think about a very ICS or OT heavy sector like the water sector, for example, they're going to have a very different implementation model from other sectors that are more IT driven. And so it's going to necessarily look very different for each sector.
Okay. And Graham, curious for your perspective in terms of, we've obviously talked about the national implications here, but NIST is, I think, is long recognized as producing international documents. What are your thoughts on that in terms of the perception globally of what's coming out from NIST?
Yeah, it's quite a nuanced picture these days. So that we operate with organizations who have customers in at least 60 countries in some cases. And there's a sentiment around the way that we should be doing this transition that could be quite different in the Asia Pacific region maybe than it is in North America. And so that actually drives the need for this foundational approach where we're thinking about our data, where it's going, how we're protecting it with the cryptography we have, because we may end up using different kinds of solutions in different areas. It's actually very complicated. There's part of it, having to navigate those standards. It would be nice if we could all just agree around the same things, but it doesn't look like that's going to be exactly the case in the end.
Yeah, so I think that it's probably going to come down to some. It's almost like, I think, CISA calls national critical functions that weave across different sectors. It's almost like that, except it goes international as well, right?
Yeah,
I mean,
right.
that's the thing, because to your point, there's different ways of solving the problem in different industries, but globally there needs to be some degree of interoperability, obviously, right, in terms of the standards.
Yeah.
Ken, what are you seeing from that perspective, I guess, in terms of international aspects of PQC?
Yeah, that's an interesting question. So I think part of some things that we're seeing here are this. Almost every customer around the world has one big giant problem set. We all know that inventory needs to happen, but inventory is a really, really big word. It's a really big word, and you could spend an awful lot of time on it. So generally, one of the discussions that I've been having recently is, start to think about where you believe that you have the most risk or exposure. If it's, let's say, stuff transiting the internet, if you're worried about store now, decrypt later type of attacks, that might be the place that you start to emphasize in terms of providing inventories and controls of that place. So it's understanding that risk surface, and that conversation translates very well internationally, no matter where you go, because that inventory is a really big deal.
Yeah, and it's funny because I think even just this week, if not a little prior to that, I'm hearing many more discussions around boundaries, and and it's hard to say everything's safe inside this boundary, but certainly scoping of the problem, trying to understand where the assets are. And a lot of that leads, of course, to data and the protection of particular data. Yeah. Are you seeing, Mike, from your perspective, beyond national security, but just more generally, the use of data as a sort of a touchstone in terms of where that data goes and how it's protected? Is that an aspect you tend to look at?
Data, I think assessing the value of the data. So a lot of the military communications is on links as opposed to data. I think in the commercial world you're going to be very focused on data. I think for us, what we're looking at is more nation state. What is the cyber concern, and how are we protecting our networks? We still do a lot of hard shell soft innards, and Zero Trust is kind of moving away from that, but that's kind of the way we think. When we look at actors and look at what they're coming on our networks to do, it's not always get at data. It's to disrupt. It's to see what's there and how they can use it. So when we're thinking about this, that's kind of one of the reasons we sort of look at this transition as a means to sort of up the game, not just cryptographically, right? Yeah. I mean, these NIST algorithms are better in every way. They're not just post-quantum secure. So yes, data. Obviously classified data, but.
And I think in some of the discussions at the event we hosted last night, I think it was that sort of led to crypto resilience. And as you've alluded to, I think both Ken and Christian, around additional things that can be done. I think there was a phrase quoted last night, we're making, was it key management sexy again or something? all of the governance aspects and the way we kind of, maybe it's a little too jokingly, but we always say it's never a bad time to look in the attic, right? There's always things to find there. And I think, unfortunately, the way that cryptography has been, it's endemic now, and it's coming through many different doors, and lots of developers calling libraries, or through supply chain. Like, there's so many ways that it's now embedded and endemic that sort of unwinding a lot of that is going to require a lot of top governance to be rectified as well. Any thoughts on how you get, because again, people can say, well, it's still years away, right? And we are trying to say, but if you know now, then at least you can start to take steps. But any thoughts on how to elevate that messaging a little bit and get away from the bits and bytes of the algorithm and sort of at a higher level? This is how it's going to impact your agency and your availability to citizens, or your business and your availability to make money. Any thoughts on elevating that message a little bit?
Well, I'll tie in from some of the other conversations we've had this week and just say that I think the quantum affiliation of the effort actually makes it more complicated, because quantum is just inherently difficult to understand. I don't understand quantum physics at a deep level. I understand the implications in a computing system and in an infrastructure system much better, but tying it to quantum computing specifically, I think, clouds it a little bit, and I can certainly see it. I haven't had the conversation, but I can certainly see it making the investment a harder choice for an executive or for a board, because it seems, one, far away on an undefined timeline, and then two, just inherently complicated, when in fact it's an IT upgrade for most organizations, and that's something that's very well understood. So.
Yeah, if you took the word quantum out of it, I think it'd probably have a much better reception, because it doesn't evoke, quantum leap and all that sort of thing, right? It's very far-fetched. Any other thoughts on that?
So, you mentioned supply chain, right? So this is one place where we have seen this effort, whether it's inventory or modernization or PQC, having an impact on top line. People are starting to put into their vendor questionnaires for people like us who sell software, what is your crypto inventory and your agility plan and your PQC upgrade path? And so if I'm a software supplier and I'm supplying a large bank that's running that program across all of its vendors, now it's sort of a business enablement to be able to give an up-to-date inventory and control with every version that I release. So we are seeing that starting to happen, which is quite interesting.
And I guess on the other side, if you're not taking the steps to do to repair, and something does happen, which, by the way, we don't think they're going to, and no one who has a cryptographically relevant quantum computer, I would suspect, is going to put it on a billboard. You know, it's going to be something they'll have and they'll use until they're not able to use it anymore.
Yeah.
So and again, we don't want to debate whether it's 5, 10, 15, 20 years, but at some point, if it happens in the future, sort of scrambling to get out the door at that point is going to be very hard. There's going to be resource restrictions and so on, right? So, Ken, did you have some thoughts on elevating the message and getting it out to a broader audience?
Yeah, I really like your idea. You know, I wish I had the magic wand to go back and remove quantum from the discussion, because really, I think that the real focus for every CISO is looking at risks, identifying what the risk surface is, and then turning around and saying, where do I need to apply good cyber hygiene principles in order to address this space? And realistically, I think there's a different aspect to it as well, which is most people think of cryptography and they only think of encryption specifically, but mishashing, signing, and all the other wonderful things that we use it for. And if you start to look across your entirety of your IT stack, you may find that you are using a lot more cryptographic algorithms than you had actually thought through once you start doing the cataloging and inventory of your system.
That's what that's where I was going to go. It would be heresy for me to say, it's not all about the crypto. But you said get rid of the quantum.
Yeah.
We're going to have to get rid of the crypto, but the problem is it underlies. It has to be rock solid. Cryptography underlies so much that basically you need people who understand cryptography and where it is, and sort of trace that up to where it matters for authentication, and for single sign-on, for all that stuff.
Yeah.
No, I agree, and maybe even a level higher as well. I mean, to Ken's point, there's been a lot of discussion around confidentiality of data, right? But I think integrity is going to be a huge factor, obviously, on the internet and financial transactions and the like. And I know this is not how availability is properly defined, but then, if there's a breach or if there's an attack, systems will shut down for an indeterminate period, and that lacks availability then, or produces availability.
And that may be the whole point, is just to shut things down.
Right.
So availability is very much,
Yeah. So I think there's a lot of discussion still to be had around that, and try to, again, not being alarmist, but saying we got to start taking prudent steps at this point and start moving things forward.
Yeah.
Sorry, did you have something to add there, Kristen?
Well, I would just say that some of the places where availability is the biggest concern, right? OT environments are actually where you have the hardest and most expensive replacement life cycle for equipment, and so that, to me, some of those are the hardest edge cases to resolve, and so I think that's exactly right.
Yeah. So when July comes around, right, and these standards come out, again, I think people are thinking, well, that's a step, but it's going to promulgate a lot of different discussions globally, and people are starting to, we're seeing clients now that are, I think, a little more serious than they were 6 months ago. And again, there's a notion, and I've been at some events in the last year or so where, especially in the financial sector, regulators are starting to listen, right, starting to lean in a little bit. I mean, I don't know what they would regulate. I personally, and we as a firm we don't think that regulation is the answer as a driver to make change. We think it really needs to be around risk management. Unfortunately, that goes back to trying to calculate the risk and set it up. But none of us are regulators here. But any thoughts on where that would be? Is it sort of light touch, or maybe down the line pointing to existing NIST standards, or is it just better that it's done as a risk management approach and regulations will play out as they play out, or not?
Not only are we not regulatory, but we don't directly interface with. I mean, from a standards point of view, actually, we do kind of interface with some of the commercial vendor space.
Yeah.
What we found from our point of view is when we go talk to them, they say, "We're so glad you told us what to do," and we say, "We didn't tell you what to do. You don't have to do what we say. In fact, if you're not in the national security system, this should mean nothing to you, but it does. It's a stake in the ground, right?"
Yeah.
So we've found that. That either that stake in the ground can become a target for an industry, for a vendor consortium or something, to sort of say, okay, that's a starting point. Do we want to be a couple notches down? Do we want to be, do we want to be like there? But so I don't think regulation is the way to go, but we're going to need to start saying increasingly hard things about what people should be thinking about anyway, and maybe what they should be doing.
Yeah, and maybe that goes back in some way to 10 years ago or so, the NIST cybersecurity framework. There was a lot of back and forward on that, and it ultimately ended up being, here is the outcome that you should achieve, and then it was informative references about how that outcome could be achieved. In a sense, I felt like that was sort of saying, you should do this, right? Or someone else is going to come in and start to regulate. And I feel it's very much the same, but with the additional ambiguity of time, so it's much more important to do it voluntarily rather than wait. Do you think that's where it'll end up be, just maybe an amendment to the CSF or something like that in terms of giving guidance, informative guidance?
I think that would work really well. I think that would be good to build in there, and I would not be surprised, and I think it would be helpful to have sector-specific or industry-specific playbooks that emerge as well, right? So I would fully expect the healthcare sector to identify its own set of priorities and its own framework that maybe is a tearaway from the CSF and whatever comes out of that.
Yeah, and part of the reason I brought up regulation was, non-attributed. There was a person at an event last night from an undisclosed industry, but they said that regulation would actually help to get that elevated messaging, right? Because then it's something, but that's not the right way to get that elevated messaging. I think it's much more about getting the messaging right so that it's understandable and it's not readily dismissed by saying, well, it's years away. So I think we still have, as an industry, I think we still have some work to do there. Ken?
So, I like looking at history, and one of the things that's kind of interesting in this pace is for IPv6, we had a lot of governmental regulations. Even all your products had to comply with V6, all across the board for everything. This is when I was back at Cisco, and that did nothing to advance IPv6 at all. So the regulations actually made everybody rush to a goalpost from a vendor perspective, but in doing so, they missed all of the best practice sharing and all of the tools that they could have created in ways to make it easier for customers to actually adopt V6. And so I'm not sure the regulation is the right way to do it. I think that, sharing best practices, getting consortia involved and stuff like that is probably a more better and easier way to provide that.
And we have the opposite problem. No one says, thank you for telling us what to do. Like, everyone says, how dare you tell us what to do, right? And so whatever CISA provides is much better when it's done in full contact with industry, back and forth, and then coordinated with the people who actually have to implement it, right? So we have a national security and a national cybersecurity imperative to maintain that is layered above that. But when it comes down to actually providing guidance and frameworks, it's much better when it's done in coordination rather than handed down as a regulation or as a edict from on high.
Let me clarify that. The first thing they do is they say, thank you for telling us what to do, and then they look at it and then they say, why did you tell us to do this? And that may be how this goes. I mean, that's how it goes with the services, is we tell them what to do, and then they come back and say, yeah, but we got this corner case, and then you start working, right? And that may be what this comes down to, is there's going to be some back conversations like this and back and forth, right?
Yeah, and that's ultimately where we're trying to get to, is that there's a dialogue, right? There's a dialogue between development of the standards, next stages, globalization, so that it can be done in an orderly way again with a full understanding, rather than someone say, I'm going to pick this up in this industry, you must do this, because I think that's not going to end well for, and again, given the timing, it's not like a normal, technologies emerge, there's risk apparent with them, and then regulations kick in. All those things are kind of mixed up, just the way that this particular technology is emerging. It's not like other ones. You want to add something to that, Graham?
Yeah, I'll just say that we see that there are other ways to kind of introduce good practices into an industry that don't require kind of full-on regulation. So you can see that, for example, there's this FedRAMP standard that the US government has for if I'm going to offer a cloud service to a federal customer. That already includes some quite nice requirements around, well, quite nice, speaking as a cryptographer, quite nice, not that nice when you're supplying, but requirements around cryptography inventory. And you could sort of imagine this kind of thing drifting a little bit further across without requiring anybody in a regulatory way, but it's an interesting way to give a bit of a kind of carrot as well as stick to the industry to make.
I think that's right, and I would add that as a CISA representative, our Secure by Design work I think wraps up a lot of these conversations nicely as a way to not regulate but encourage, in the marketplace that there's an incentive to provide secure products, and there is an incentive that exists already to increase the standards at which you're developing products. And so I think this whole discussion nests very neatly under that concept.
And there might be an aspect of market differentiation as well. We've not really
Yes.
talked about that.
Yeah.
I think when we did the work with the World Economic Forum, there was 4 sort of drivers that were contemplated. One was regulation. One, in fact, was do nothing, just wait and hope, was one of the drivers. I mean, it's not really a driver, but it's a state, I guess. The other one was, I've lost it, just what you said there. I've lost it.
Market differentiation?
Differentiation, sorry,
Yeah.
market differentiation was the other one that I was recalling. So I mean, that could be a driver, right? And we actually are seeing some of that. I happened to be in a meeting last year, and I put forward a position that I didn't think that a lot of companies would immediately adopt as soon as the FIPS came out. They might wait a little bit, but there was a CISO there of a major organization that said, no, we intend to do it from day one. Now, we'll see how that all plays out, but that sort of changed our perspective a little bit in terms of what companies might do to show that market differentiation, which will be another factor. So we'll see how that plays out. I think maybe at this point we will we'll open it up to questions if there's any from the audience. So there's 2 microphones there, and looks like we've got 3 in the works. Go ahead.
Hi, I have a question for Graham about the crypto discovery tool, your old baby CryptoSense. How comprehensive is it? Can you really rely on it to give you full coverage when you're doing discovery? And then I have a follow-up question.
Okay, right, yeah, so you're inviting me to give a product pitch, so that's right, but I'm going to resist the temptation to go through the whole thing. So we like to think we have the most comprehensive cryptography discovery tool on the market, but we're always adding more coverage. A particular focus of what we do right now is most CISOs have in their armory already tools which have some interesting cryptography inventory information in, alongside other stuff. And a big focus for us right now is to take advantage of that, as well as our own kind of scanning and tracing and these sort of tools, to bring all that into one place and aggregate it, provide actionable insights on it, make it kind of useful. So happy to talk after about the ins and outs of what we cover and what we don't cover, but that getting that coverage better is one of the main kind of strategic focuses of that.
And maybe just to add, to be fair, as an integrator, right, we've been looking at a lot of different tools to do discovery, and this is a fairly nascent market, and I commend the vendors, moving forward and trying to get as much coverage as they can. But it's an emerging topic, and the questions that we pose to our clients in terms of where is the cryptography, there's a lot of different places, and so getting tools that can do all that is, it's part of the challenge.
I'd even say probably, if I was to look at the journey of coming from where we are today and actually being fully new crypto enabled, you're going to spend, any of you will probably spend 60 to 70% of your time in discovery and planning.
Yeah.
Not even implementing, just discovery and planning is going to chew up about 60 or 70% of the time.
And so you said I had a follow-up question. Was it
Yeah.
dependent on the answer, or is it the same follow-up question?
No, I was going to ask it anyway. Yeah, so how much hand-holding do I need if I deploy this tool? Does it come up with professional services, or can I just use it without any help?
Well, we do have a number of GSI partners who are able to provide that kind of service, which I should obviously mention. But so it's a graduated scale. There are things you can do with no help at all, probably with inventory data you already have, and there's like nasty, long tail cases where you might need quite specialized services help to get the kind of access you need, OT and these different sort of areas. So there's a whole kind of graduated scale of where you can get to and where you should start. But I don't want to take the bait too much to give a big product pitch, but I'd be very happy to talk about it later.
Okay.
This
I'll
might
come
be a
and see you
good.
after.
This might be a good time to put a plug in for the National Center of Excellence for Cybersecurity.
Yeah, good point.
Their post-quantum cryptography migration project. And I don't have a nice little card or thing, but they're publishing it. They have a consortium, a group of companies that are looking at the different aspects of transition. I'm fairly certain
we're in
Sandbox IQ is one of them, and Dell is also. They're going to they're publishing a document series. It's Special Pub 38. 1838, if you remember that. But that should provide some of the answers that you're talking about across products.
Bill Newhouse would be good to connect with at the NCCOE. He's
Thank you,
leading
gentlemen.
that project.
Hi, thank you. Ken, I really appreciated your comments on Y2K because I've been using that analogy. The difference being, of course, there's not a firm date, right? We're a little bit guessing. And I think it's better to spend the resources and not be late than to not spend them and be late. I also, Christian, liked your comment about IoT because I think as we think about crypto agility and all the benefits that'll come from it, that's obviously something we haven't solved for. My question to all of you is, with respect to alternatives to post-quantum cryptography, specifically things like QKD, and we've seen the European Commission recently comment on that, what are your thoughts about a hybrid approach for organizations, perhaps depending on risk tiering of assets or limitations of the various solutions having to do with distances and things like that?
So why is everyone looking at me?
No, I can take that as a moderator. I just feel I should offer it to the panel.
So NSA has a stated position on QKD specifically. Some of the non-stated positions are you could probably do 2 or 3 PQC transitions for the price of doing QKD kind of globally. We see a number of complications with it. We think that we're looking, so we have long, and I'm speaking for NSA and national security systems. There are other financial and health systems that will have these issues, but we have long data protection, and we need to get to the shortest path to post-quantum protection, and that's post-quantum cryptography. So that's where we're putting all of our effort, because it's going to take all of our effort to get there.
Yeah, as a follow-up to that, and you just reminded me, I wanted to ask your view on Harvest Now, Decrypt Later.
On what?
Since Harvest Now, Decrypt Later, since you mentioned you have long data protection needs, and any views on how that should influence how rapidly you get to protecting things in transit now?
How?
Rapidly you should get to protecting things in transit.
Well, for us, it would be 10 years ago.
Yeah.
I mean, that's an excellent question. So I should say that a lot of the people have said, well, the FIPS will, the phrase we use, the FIPS will drop in July, right? And then the standards, and then this, and then that. Actually, a lot of this has been happening in parallel. Standards have been, not just cryptographic standards, but the protocol standards. So we're quite hopeful that we can meet our stated timeline that's in NSM 10. But again, I mean, the faster the better for us, especially, and we feel like the faster the better for everyone. But that's kind of their assessment.
Thank you.
Do you mind if I feel like I've used my moderator words for the day, my quota. Do you mind if I wanted to go to the QKD and PQC thing. Just, I think the challenge, so 2 things. One first of all, we supported the World Economic Forum to start up their quantum security program. As part of that, one of the big benefits was getting vendors and other participants together, universities and so on. And we kind of had that debate a little bit, and I think where that landed up, and it's in the report, was really that PQC is sort of the primary way for mitigating the threat. QKD may have some other complementary applications. And then QRNG, I think, my words, but the jury's still out a little bit as to the need to get to that level of randomness that's hadn't been proven you needed that at this point. Our view, though, as a firm, I think, is that, and I've seen this before personally in the biometrics industry, where there were two types of technologies. It just causes a little bit of confusion in the market. Now, I'm not saying that's the reason that one should choose one or the other, but they're very different technologies, and the word quantum is the only thing that links them. And if I was to take the word quantum out of quantum cyber readiness as we view it, there's a future threat that may be likely in the next 5 to 10 years, and you need to replace your cryptography. You really don't need to say quantum for that, but for QKD, it's an inherently physical, hardware-based solution, whereas PQC is upgrade of existing cryptography, right? So that they're very different, and it's sometimes the conflation and comparison of the two that causes more challenges than any distinction between them.
Well, I guess I have a question that kind of plays into that a little bit. So with what we've been talking about with trying to implement some of this newer cryptography today, you touched on it earlier, we need to be looking at this as just an upgrade to our IT systems, right? What does that look like from a hardware standpoint? So if I'm trying to upgrade to this new cryptography, can my hardware I'm running now, like how much of that do I need to upgrade? How much of it is going to get left behind if I need to maintain my same processing power? Or do I need to look at buying top-of-the-line models and budgeting for that? Or do I need to even wait a few years for new relevant equipment to be even created so it can handle that type of load?
Yeah, well, I guess I'll take that. So it really depends, and I'll give you the dimensions of thought. The first one is this: if you have cryptography that has been implemented in hardware that's not easily upgradable, think of IoT or embedded type of devices, you're likely to have to do some type of upgrading cycle. If you're running cryptography in software on top of systems, the degradation for most of the algorithms is minimal. I personally have not seen a huge degradation in terms of performance with the new algorithms, at least early stages of new algorithms, on any type of hardware that we've seen. So I'm not sure that it's going to be you must replace all of your systems that are running cryptographic algorithms in software. The hardware ones where it's embedded may be something that you may have to upgrade.
Awesome, thank you.
I don't have anything to add to that specific question, but I will just say that's another plug for testing before the standards
Yeah,
are actually
absolutely.
released,
Yeah.
right? So
Absolutely.
that you actually know and can deploy at scale when you're ready or when you need to.
And Ken, just to round out your response to it, I believe you have a test. You actually have test beds where you run these things, right?
Yeah,
You're not just
absolutely.
saying your belief is you
Yeah,
run
absolutely.
them. Yeah.
And on different types of hardware, CPU complexes and stuff like that. So we do have a lot of experience in that.
That's one of the reasons lattices were chosen because they're performant, right?
Yeah.
Although they do have big artifacts, they have big keys and big,
Yeah.
right? And that affects the protocols, which is that's kind of my bread and butter is making sure that because we require big keys, we need to make sure the protocols. So you may be replacing more software than you thought because it's not just the crypt libraries, right?
Yeah. I only talk about the hardware impact to the
Oh
software.
yeah.
not-
Oh, okay, right.
Yeah,
Yeah.
but the OT devices, though, you had mentioned earlier, Ken, right? That's a
Yeah.
whole other
There's a
conundrum,
whole-
right?
whole other-
not just
a whole
processing
other
time,
thing
but
there,
getting
yeah.
to them and doing the upgrades and things. I mean, that's where I think we'll start to see some of the supply chain considerations, just obsolescence, planned obsolescence of particular devices and things. I mean, that's where, again, I think if you get a much better sense of how long it's going to take, you can start to plan out, is it worth replacing these things, or do I just let that play out while I'm replacing everything else, right, in terms of prioritization?
I will say, that benchmark that I gave around the 60 to 70% of time just in identification and
Yeah.
planning, that number, I didn't pull that out of the air. That we actually went through our lab and looked at every single device that was plugged into our lab, every single operating system, looked through all the cryptographic libraries in operating systems, in NIC cards, everything else, and we spent an awful lot of time doing that.
Great. Well, let me see. Is there any other questions? If not, then I'd like to again thank the panel. Thanks so much, Mike, Ken, Christian, and Graham. Thank you very much for your excellent panel.
Thank you. Thanks.